very good evening to all of you. My name is Rahul Kanyal and I'm going to take you through industrial engineering questions. And last time we have had a discussion about queuing theory and we took some questions over here. And today also we are going to continue with the same momentum. All right, so let's get started. A very good evening. Are you guys there? And if you are there, how are you all? Just type in your responses, guys. Okay. Okay, so how are you doing? Is there anyone out there? Okay, so let's begin. Okay, so we have SSC JEE Mega Mock Challenge 4th March to 5th March. You can register for that. All right, if you are interested for SSC JEE. All right, so Murli, yeah, Mechanical Murli, nice name. Okay, I like that. A very good evening to you. Thank you for tuning in. Okay, now actually we were doing the questions of queuing theory, and if you are new to this, all right, then just be here. All right, I will tell you the formulas that will be used in these questions out here. Okay, and because this is just a formula based chapter, so I suggest you cram or remember all the formulas, guys. Okay, all right, now how many of you have seen my previous videos in queuing? How many of you? So we are just going to discuss the questions of queuing. Otherwise, the theory has already been discussed. If you have not watched the theory, you can go back to the first, the first day that I took queuing theory. I think that would be 2-3 days back. Okay. So can you please try this? Poisson process at the rate of parts arrive according to a Poisson process at the rate of 0.35 parts. Okay, so sorry for that. 35 parts per minute. So we say that lambda is nothing but arrival rate. Okay, arrival rate. So it tells you the rate with which parts are arriving, customers are arriving. All right. So yeah, Dilip, so I think if you have watched the videos, I think you can try that. Okay, so lambda is nothing but arrival rate. Okay, so that is nothing but 0.35 per minute. Okay, can you please tell me what is mu? Service rate, arrival rate. Mu is service rate, and I'm going to write 1 upon twice minute. We have discussed it, right? Whenever a mean is given for exponential distribution, okay, the rate is nothing but the reciprocal of the mean. All right, rate is nothing but the reciprocal of the mean. Okay, and this is nothing but 0.5 per minute. This is what we have been talking about, right? Okay, so yeah, Yash has already calculated that. Good, Yash. I'm sure that. Okay, let's see. I cannot comment on the accuracy, but let's see. Okay, how much should be the answer of it? Okay, probability that a random part arrival finds that there are already 8 parts in the system. So what do we need to find? We need to find that probability of 8 parts in the system, and I have told you that that's given by rho to the power 8 into P0. Yes, rho to the power 8 into P0, where rho is nothing but lambda upon mu. Okay, in this case it becomes lambda is 0.35. all right, mu is nothing but 0.5. okay, and P0 is nothing but 1 minus rho. So can you please just calculate all of these and tell me the answer for this? Okay, this is what you need to find. So just do the calculations, guys. Okay, and let's see if you can do that. Chalo, let's do this. Come on, guys, quickly. Let's calculate this. Okay, how much are you getting? Rho to the power 8 into P0. Rho is nothing but lambda upon mu, that is 0.35 upon 0.5, and P0 is nothing but 1 minus rho. Chalo, come on, guys. Let's do this. How much are you getting? 0.5. There's no option like 0.5 there, right? So, okay, fine. So, I don't have a calculator over here, so you need to do the calculations, all right? So, how much are you getting, guys? Come on. So, rho is this thing, okay, 0.35 upon 0.5, and yeah, 50. How much are you getting? 0.01729, 0.01729. So, you're getting a C. Is that it, guys? Yes, so it has to be C, all right, 0.01729. So, yeah, good, Ankit, good to see you again, all right. Yeah, chalo fir, theek hai? That's what we needed to find. This is the formula for that. 8 parts in the system, rho to the power 8 into P0, and rho is given something like that, and P0 is nothing but 1 minus rho, right? Okay, fine, chalo. Is it good? Hello, the next question. And let's see how much of accuracy do you have, guys, all right? And just type in I if you could solve it correctly. Okay, just type in. I want to see those people who solved it correctly, all right? So just type in I. Okay, let's move to the another one. Okay, now this one, we are not going to take this one, all right? This is a bit controversial, so let's skip that. Okay, so let's try this. Okay, so Yash says yes. Okay, Yash says yes. Okay, fine, good. Arun Sharma also says yes. So Dilip, Yash, 2 guys, 3 Prajot. Okay, 3 guys got it correctly. Okay, good to see that number. Okay, guys. Okay, see. So this is also a check of your accuracy. All right, Mukesh, a very good evening. Hello to you. Okay, so what do you think about this? What is the probability of 3 arrival in the system during period of 30 minutes? And still I have not discussed something like this, so it's fine if you're not getting this, okay? I'm going to give you 2 minutes. Try for 2 minutes, guys, okay? And then I'm going to tell you this. So, what do you think it is? Come on, guys, keep on liking this, keep on sharing this, because it'll give life to me, it'll motivate me. And let's also enjoy, you know, let's not be very dead serious, all right? Abhishek, a very hello to you, hi to you. Okay, so, okay, fine. So, arrival rate of customers is, so what is lambda? We always talk in terms of lambda and mu in this, right? So, arrival rate of customers is 8 customers per hour, okay? And the service rate is 5 minutes per customer on an average. So, what is mu? Mu is nothing but 1 upon 5, okay? Minutes equal to 1 upon 5 into 1 upon 60 hour, right? That is nothing but 12 per hour, right? Yes, so what is the probability of 3 arrival in the system during a period of 30 minutes? Okay, now there's something called, now listen guys, okay? Yeah, Mukesh, it's very good that you're getting, 65 marks in GATE 2020, all right? And let me tell you that you can try for MTech through research. Mukesh Jat, okay? MTech through research you can try. All right, Abhishek, yes, Abhishek Mandal, I have taken your name, okay, don't feel bad about that. Okay, so there's something called a probability density function, okay. So in case of a Poisson's distribution, okay, so let me tell you, so I'm going to just erase this, okay, because we don't need this actually, this is just for distraction. So in case of Poisson's distribution, you need to remember this formula guys, okay, Poisson's distribution. Okay, so probability of R arrivals is given by e to the power minus lambda t to the power R upon r factorial. Okay, this is nothing but probability of r arrivals. This you need to, yeah, okay, fine. So this you need to, cram, okay? Cram is remember, all right? And you also need to work in your English, guys, okay? Okay, guys, okay. Bhushan, I'm 32, still I have a chance for GATE exam. So what is the upper age for that, Bhushan, okay? Okay, I'm in 12th, I'm not prepared for JEE. Please guide me, sir. Abhishek Mandal, okay, we'll talk about that, Abhishek, okay? Don't worry. We are going to talk about that. Slowly, let's take it, okay? So lambda is given to you. Okay, then what is time? Time is here. T is here, 30 minutes, right? That is nothing but half an hour. All right, so what is the probability of 3 arrivals? 3 arrivals means what is 3? R equals to 3. So can you please just plug in these values in this formula? So I'm going to just plug in these values in the formula. So P of 3 arrivals equals to e to the power minus, what is lambda? 8 per hour into what is T? T is 1 upon 2 hours, all right? Then lambda T again is 8 into 1 upon 2 lambda T to the power R, that is cube upon 3 factorial. So how much are you getting this? This is 3 factorial, right? So how much are you getting this? Chalo, Dilip Verma, well done. Yes, you are correct. Okay, let me tell you that you are correct. Good, Dilip Verma. Okay. Yeah, so Abhishek, coming back to your question, you are still in 12th. Firstly, obviously, you need to do, if you are looking to do an engineering, all right, then because you are in 12th, so let me tell you that you need to do it in computer science. Okay, because this point of time, that will give you the maximum scope. Everything is related to computers, right? Okay, so that's why you should be doing that. Okay, Abhishek, if you are into engineering, so how much are you getting? Yes, well done. So you will be getting this one, 0.1953. Okay, so I hope I answered to Abhishek Mandal, all right? Yeah, good, well done. So how many of you got it correctly? Just say I. I means this I, okay? I. This is correct and this is not correct, okay? You know what I mean, right? Come on, chalo. Just type in I. Yes. So how many of you got it correctly? I. Murli says I. Good, well done, Murli. Yes, Dilip, I too. Yes, Murli, I got it. I got your response. Yes, so 1, 2, 3, 4. Mukesh also says I. Good. But the point here is that you need to remember this formula, Poisson's distribution. And why do we have to use Poisson's? Can you think about that? Why did we use a formula for Poisson's? Can you think about that? Okay, good. Mukesh also got it correctly. So yeah, 3-4 people got it correctly. Now, why did we use the formula for Poisson's distribution? That is the question. Why? Did you ever ask this? Did you ever ask this? Okay, so let me tell you that obviously arrival in this model is assumed to have Poisson's distribution, okay? Class number 1 that we talked about. Yes, you are right, exactly. Arrival rate is Poisson's distributed, all right? That's why we use the formula Poisson's. Is that good? That's why. Okay, yes, good, well done, Yash Bhatt. Good to see that, okay? Chalo, it is just, formula based thing. And I have already given you the formula, then this becomes really easy, okay? Okay, chalo, let's move ahead. Chalo, let's do this. Okay, let's do this, and I'm going to write, yeah, Ankit, you also write, good to see that, okay? Come on, guys, and just do one thing for me, please like the session. Okay, that will give an additional boost to me, and also share this with someone who really likes this, or who really needs this, okay, not likes it. So arrival rate is nothing but 12 per hour, so lambda is 12 per hour. Serving rate is 24 per hour, so mu is 24 per hour, all right. The expected time that a customer is in queue in minutes is, so what do you need to calculate over here? Yes, Mukesh, yes, you're right. Arrival rate is based on Poisson's distribution. Exactly, absolutely, I agree to you. So what do you need to find in this? Those who have, joined previous classes, what do you think do we need to find in this? Okay, those who have not joined, you can, wait for this, okay? Because I'm going to write the formula over here. It's very straightforward. Everyone can do that. Okay. Yash says 0.0833. So what do we need to find, Yash? What exactly do we need to find? Yash, you have calculated 0.0833, all right? So what is that you have found? Okay. So Q, see, expected time that customer is in queue is nothing but we have to find WQ, okay, waiting time in the queue. Whenever, guys, this is very important, okay, whenever you see this thing, expected time, whenever you see that, expected means average, always. Okay, so it is just asking for WQ, that is nothing but lambda upon mu into mu minus lambda. So how much are you getting that? That is nothing but 12 upon mu is 24, and this is again 12. All right, that's what it is. Is it good? Lambda upon mu into mu minus lambda, right? Is it good? So what we are getting here is 1 upon 24. This is what? It's in hours, right? So 1 hour equals to 60 minutes. So it will be like this, 60 upon 24 minutes. What is this value? Please tell me. Come on. So that should be the answer, right? So what is this? 60 upon 24. Just calculate this and you're done, all right? Yes, so 2.5 people are saying. So I'll take that, 2.5. Okay, that is nothing but 2.5 minutes. All right, guys. Now just type in whosoever could solve this. Just type in I, all right? Let me see who are those people who are able to solve this. But still, even if you're not able to solve this, you just need to cram these formulas. Once you remember these formulas, guys, life becomes really easy in queuing theory, all right? Yeah, Dilip, yes, good. Good to see that. Okay. How much is this value? Yeah, 2.66 or 2.5. All right. So I'm going to just confirm it. I have a mobile with me because one of the answer, because I just like to calculate everything using calculator because that's what who we are, right? Engineers. So yeah, 2.5 is the correct answer. So the next question coming up. Okay. Chalo, now this one, I'm going to give you 5 minutes for this. Okay, I'm going to give you 5 minutes. Don't go away, okay? Don't give up because a real warrior never quits. I'm going to repeat that. A real warrior never quits. So just try this, okay? Don't give up. If you give up here, obviously you will also give up there in the final battle. Chalo, good. So Yash got the previous question correctly. Ankit, Mukesh and Murli as well. Chalo, let's do this. Okay? Chalo, let's do this. Just think about it and just write what is lambda, what is mu, because these are the two parameters that we need here, right? Okay? So what is lambda? Lambda equals to the radial repaired in order. Okay, so what is lambda? Average rate of 15 for 8-hour day. So what is that? So 15 per 8 hour. This is lambda, right? And replacement expected idle time each day is 3 hours. So idle time equals to 3 hours. Now let me tell you that this is not very straightforward question, all right? This is not very straightforward question, okay? This wire gets on entangling, okay? So sorry for that. So whenever you think about idle time, okay, just look at this statement, idle time. So can you relate this idle time to something that you already know in queuing theory? Can you relate this idle time to something that you already know in queuing theory? Just think, guys, okay? Don't give up. Don't give up. Just don't give up. So another question that you might want to ask is, what can I calculate using these values? Now, another hint, all right, another hint, because you also need mu. So can you calculate mu using these two informations? Because without mu, there's nothing out there. Okay, you need a value of mu, right? Then only you will be able to calculate whatever this is. Okay, if you're getting this, it's fine. But still, you need mu to proceed, right? Can you please try to find out mu in this? So that is a big hint, guys, okay? And can anyone tell me, type in there, what should be the approach to find mu? And for that, I have already told you that, can you correlate this idle time to something that you already know in queuing theory? That's what, I would suggest. Just brought into the repairman shop, so yeah. So can you find, probability of idle system? That's what I mean, okay? Probability of idle system. Can you please find that? Or the probability of, I just need to find probability that there's probability of 0 customers in the system, right? Yeah, 0 customers in the system. That is nothing but, what is that? That is nothing but 1 minus lambda upon mu. Right? So now look, everyone, here, okay? Now comes the jhatka part, all right? Okay? For in this scenario improvement, I'm not making a mistake by taking drop. Yeah, Mukesh, I also believe that, you should join MTech, all right? Don't drop it. This is my frank suggestion to you, all right? So that is nothing but mu minus lambda upon mu. Okay, this is a probability, all right, of 0 customers or idle, or the system is not busy. That's what it is. Okay. Okay, is that it? Yes. So what it means is, in mu hours. Okay, in mu hours, mu minus lambda hours are free or idle. Okay, in mu hours, mu minus lambda hours are free. So in 1 hour, how much hours will be free? In 1 hour, mu minus lambda upon mu hours are free. Is that good? Is it good? Yes. So in 8 hours, because we are talking about 8 hours here, right? So in 8 hours, how many hours are going to be free? Can you please tell me? That is going to be mu minus lambda upon mu into 8. This many hours are going to be free or idle, right? Yes, Rukmani, can you please tell me what is the meaning of that? Hum bhi hain. Okay, just type in, it's fine. Okay, now this thing is given to you equal to 3, right? The idle time that is given to you equals to 3 hours. So can you please find mu from this, because lambda is given to you 15 upon 8. Can you please find mu from this? All right, so just find mu. Mu equals to how much? Yes? So can you please find mu in this? Lambda का अर्थ है the arrival rate. Okay, for example, see, repaired, if the radio repaired in order in which they come in and the arrival is approximately poisoned with an average rate of this. So arrival rate is lambda. Okay, arrival rate है lambda. जिस rate से, जिस speed से लोग अंदर आ रहे हैं या फिर radios अंदर आ रहे हैं, whatever that can be anything. Okay, लैम्डा का मतलब वो है. म्यू का मतलब क्या है? म्यू का मतलब ये है कि जिस रेट से हम सर्विस दे रहे हैं, दैट इज व्हाट इज द मीनिंग ऑफ म्यू. सो कैन यू प्लीज गिव मी म्यू? व्हाट इज म्यू? कम ऑन गाइज. Ankit says it's 24. You know, lambda is given to you 15 upon 8. All right, and mu, you need to find mu. Okay, that's all. Okay, so mu people are saying is 3, not 24, Ankit. So are you agreeing on to that? Just plug in the values. So mu people are saying it's 3. Okay. Mu is nothing but 3. Is it 24 or is it 3? Come on. Okay, so fine. So ठीक है. Let me try this. Okay. ठीक है. So what I'm going to write, 8 mu minus 8 lambda equals to 3 mu. Is it good? Yes. So what it means is 5 mu equals to 8 lambda. All right. This doesn't look like 5. Sorry for that. My handwriting. So what it means is lambda upon mu is nothing but 5 upon 8, right? So lambda upon mu is 5 upon 8. So let's stop here, guys. Okay, let's stop it. Then okay, fine, good. Yes, okay, let's stop this. Okay, it's fine. So now अब निकालना क्या है? What do you need to find? How many jobs are ahead of the average set just brought into the repairman shop? That's the question. Okay, that's the question. Okay, Ankit, let's forget that. Okay, I'm not calculating it. So अब just tell me, what do we need to find? Just read this statement again, then tell me. All right, let's see. Krishna Ram says, Krishna, so much late. Okay, I was waiting for you. Chalo. Come on, guys, come on. So what do you need to find? That is the question. Okay, I hope this is clear to you. So I'm going to just remove this. So what do you need to find? How many jobs are ahead of the average set just brought into the repairman shop? What is that? Come on, guys, at least one answer. At least one answer I need so that we can proceed. How much extra they are doing? How much extra? Yash. How much extra? What extra? Is that the work? LS, yes, Shubham is right. So it is nothing but length of the system. All right, It is asking for that for example, let's say you are going to buy a railway ticket. Okay, then it's asking that how many people are already there in the railway counter. So that's why it is LS. Okay, how many jobs are ahead of the average set? For example, so let's say there are 100 people, okay, in the railway counter, and I go there. So what do I say? That 100 people are ahead of me, right? 100 people are already in the system, so LS needs to be found out here. That is nothing but mu minus lambda. Okay, and I'm going to write something like this: lambda upon mu upon 1 minus lambda upon mu. So what is lambda upon mu? That is 5 upon 8 upon 1 minus 5 upon 8. So how much are you getting that? That's why I said that, okay, fine, don't calculate mu, okay, it's fine. So we can do it something like this, okay, in a very smart way. All right, guys. Yes, so 1.67, that is nothing but 1.67. Good. And this was a very good question, actually, okay. This was a very good question, guys. Do you believe this was a good question? I think it was a very good question, okay. Yeah, Krishna Ram. And I hope that, you know, you all also knew, why we calculated length of the system. Lambda. Shubham, lambda is already given to us, yaar. This one, 15 for 8-hour day. It's already given to us, 15 for 8-hour day. So that's nothing but 15 upon 8 hour, right? Shubham, Shubham, yeah, Shubham. Okay, is it good? And again, I'm going to ask you the same question. Can it be 1.67 or should it be 2? Because we have already discussed this, guys. Okay. Or maybe, I also gave you something to think about, a challenge. And I like people who like challenges. There's nothing like easy question, right? If you're able to solve an easy question, what's fun in that? Fun is in, something that challenges us so that we become strong, right? For example, we go to gym, isn't it? We lift machines and all, they challenge us, and that's how we develop our muscles. So similarly here, if you do tough questions, they challenge you, you grow, you become better and better, guys, all right? So that's the whole purpose here. All right. Okay. Chalo, theek hai. So 1.67 is the answer because this average, we have already talked about this. It cannot be 2, okay? Average can be in points and decimals. We have talked about that. All right. So it has to be 1.67. Next question. Now, please do this, all right? You already know all the formulas. Okay, yeah, Shubham, you're right, Ankit. And Dilip Verma also you can write, okay? You are right again, you can write. I'm sorry about that. And still I keep on telling this, guys, okay, that you also need to work on your communication skills. If you don't, then obviously that confidence won't be surging from you in an interview. So this is what I can suggest to you. Keep on working on your communication. Now just do this. What is lambda here? Customers arrive at a railway counter at 50 per hour. So lambda is 50 hour. That is nothing but arrival rate. The speed of arrival, all right? The average time taken for issuing a ticket is 1 minute. So what is mu? I have already told you, we have done it 1,000 times. What I'm going to do is, I'm going to take the reciprocal of it. Okay, we can do that because the unit of any rate is per minute, any speed is per minute, right? Speed is what? Length per minute, distance per minute. That's why we are doing something like that. Okay, you can think like that. So that is nothing but 60 per hour, right? Nu is given, lambda is given. And the probability that there is no Q, okay. Okay, now this is a very good question, okay. Let's see how many of you can do this. It's a very good question, guys. All right, then let me see how many of you can do this. Just think about it, all right? Just range question. Oh, fine. Okay, Ankit, that's fine. Okay, we'll go back to that range question. Okay, then firstly, let's do this because this is the trickiest question for tonight. The probability that there's no Q. Yash Bhatt, V. What is meaning of that? V. Okay, Shubham, it's fine, okay? It's fine. So we'll go back to the previous slide. Let's do this first. We'll do that after this, and that's actually a very easy slide, okay? Okay, so Krishnaram says 16.67. Okay, fine, good. But still, I will recommend to think about this question again. The probability that there is no Q. Just think about it, guys, okay? Yeah, Ashish, you're right. 1.67 was correct because average can be in decimals. Chalo. No Q. Can you please think about this? Okay, Krishna, now you have changed the party, all right? You're BJP now. You are saying that, okay, I'm going to go to Congress. So at least, okay, fine. Okay, theek hai, Krishna Ram, I'm going to take that. Again, think about that, if it's correct or not, okay? Just think about, so what is the meaning of no Q? No Q means that, what? Zero customer in the system. Yes, Ankit, you're right. See, no Q means, if I tell you, you will be able to solve this, okay? No Q means that there is zero customer in the system. Zero customer in the system or one customer in the system. Even with one, you will have a zero Q, right? Yes or no? One customer in the system, because the customer, if there's one customer, he will be getting service. Okay, there will not be any Q out there. That's why. All right, so one customer in the system. Now, can you please do it? Now, I think you will be able to do this. Yes, Krishnaram, you're right. Exactly. Good, well done. Krishnaram has done that. Are you getting that? Is it good? So that's a very tricky question, all right? So that is nothing but P0 plus P1. Zero customer in the system or one customer in the system. What is P0? P0 is 1 minus lambda upon mu. That is P0. What is P1? Can you please tell me what is P1? Let's write it over here. P1 is nothing but rho to the power 1 into P0. Right? What is rho to the power 1? That is nothing but lambda upon mu into P0 is nothing but 1 minus lambda upon mu. So can you please calculate these things and tell me what's the answer? 1 minus lambda upon mu. So just lambda is 50, mu is 60. So what do you think about this, guys? Now that's a good question, right? Now that's a very good question. Chalo. Ankit, no, it's not A, okay? You got it wrongly, all right? It's not A. So Ashi says it's a B. So are you getting a B after putting this? Huh? Come on. Are you getting a B after this? How much are you getting? Krishna has already calculated it and he told the correct answer, right? Ankit, yes, exactly. Now you're getting that, okay? Yes, you'll be getting a C, 30.5% if you look at this. Yes, exactly. Carlos, good, well done. Yash, again, well done. Okay, I'm happy that you guys are getting it, all right? Yes, Tapash also says it's a C and Balu also says it's a C, okay? Yes, exactly. So Dilip, I hope this is clear to you, okay? All right. if there's no customer in the system, then can we say that the system is idle? Yes, Ashish, we can say that the system is idle, okay? Yes, that what is the meaning of idle system, okay? Okay, fine. So, okay, fine. So I'm going to go back here and please do this. This is the skipped slide. Okay, that, yeah, it was a very good question, okay? Now this one, can you please do it? Can you please do this? Come on. Yes, I know you can do this. This is very easy, okay? That one was tough. This one is a bit tricky. Can you please do it? Come on, guys. Can you please do it? So what is lambda? Always we talk about lambda and mu in this, right? So breakdowns occur on an average of 3 per day. So lambda is nothing but 3 per day. Okay, and maintenance crew can service an average of 6 machines per day. So mu equals to 6 machines per day. Okay, with a range of 0 to 7, the mean waiting time for an item to be serviced would be. So what is this that we need to calculate? First question. Yes? So what is that thing that we need to calculate? Can you please tell? Yeah, so Krishna is already told that it needs to be, okay, yeah. So what do we need to calculate here? Yeah, Krishna, I think you're right. As usual, you're doing great. Yes, so Yash Bhatt says it's a B. Okay. Yash, just think about it, okay? What did you calculate, Yash? WS. Okay, Ankit says WS. Waiting time. Then Murli, it cannot be LQ, right? Because we are talking about time here. WS people are saying. Waiting time for an item to be serviced would be. This is waiting time, Krishna Ram, okay? This is not LQ. So let me tell you that this is nothing but WQ. That is because that is waiting time for an item to be serviced. So we are talking about, yeah, exactly, Tapash. So that is WQ, okay? So that is nothing but lambda upon mu into mu minus lambda that we need to calculate. So it's all about, English, guys, okay? So English, okay, guys? So yeah, so you need to understand what is being asked. That's why I keep on telling you, work on your English. Okay, fine, Krishna, it's fine, okay? You got it correctly. So what is the answer that we are getting? Yeah, so it's fine, Krishna. I get that because you have been consistent here. You have been doing really great. Good to see you here, right? So, what is the option that you're getting, guys? Come on, type in A, B, C, or D. So, you'll be getting 1 upon 6 days. A is the option for you, okay? So, just guys, one request. Okay, and one suggestion that, you can, you have to work on your English or communication, okay? Without that, it really becomes very tough. Even if you get very good rank, let's say 200 or maybe, 100, who knows, 150. Okay, then, you can have that confidence that, once you go into an interview, you are able to face it, okay? So that's what it is, okay? So I'll see you again tomorrow, okay? And till then, just keep on revising, guys. Keep on working on your English as well. Because if you go to ISC Bangalore, they will always talk to you in English. presentations will be in English. Okay, everything is going to be in English. Okay, Shantanu Patra, I think they are going to start it again, all right? It'll resume, don't worry about that. Okay, it'll get started soon. And I'm going to see you again, guys, tomorrow. I hope that I gave you a good food for thought. Okay, and or thought for food, whatever is correct, you can figure that out. So I'm going to see you again tomorrow at the same time. All right, guys, from 9 to 10 we'll dive further into the topic, and I hope that I added value. And if you believe that I have added value to your life, just hit that like button and also subscribe to our channel. Share this with many people. Okay. Yes, I have answered to Shantanu, okay? Chalo. So I'll see you tomorrow, Shantanu. I have answered to you, so it will get resumed soon, all right? Then, okay. Chalo. Okay, fine. So, God bless you. Keep on smiling and be happy. Keep on believing. Keep on dreaming. Most importantly, think good thoughts. Good night.